Hello, this is Paul from Tech. In the previous lectures, we introduced the Epsilon-Delta definition, precise definition for a normal limit. In this lecture, I was going to introduce the Epsilon-Delta definition for one-sided limit. Okay, the right-handed limit or the left-handed limit. You will see there's only a little bit of difference. Okay. Here is the right-handed limit equals L for function as x approach a from the right side. So how do you say? Okay, and remember the intuitive definition, which means we can make f arbitrarily close to L by taking x arbitrarily or sufficiently close to a from the right side, right? Okay, so in the Epsilon-Delta language is this: for every epsilon greater than 0, there exists a delta greater than 0, so that when x between this, which means x close to a from the right side, okay, or as we say, the neighbor, which means if x go into the delta neighborhood of a from the right side or on the right side, then can we see? And the difference between the function and the L is less than epsilon, and that f is close to L, arbitrarily close. Or we say the value of f going to the epsilon neighborhood of L. Okay, so this is very similar. The only one different from the limit definition is here. Okay, it's not a minus delta to a plus delta, but only from a to a plus delta, which means on the right side of a. Still the delta neighborhood, but on the right side. Let me look at the graph definition. Okay, the graph. And the general graph is like this. If the right-handed limit is L, which means what? We can make f arbitrarily close to L. See here. We can make f arbitrarily close to L, which means we can make f go into the any epsilon neighborhood of L. How? By taking x sufficiently close to a on the right side, which means we can find a delta. So when x go into the delta neighborhood of a on the right side, can you see the graph? If x go into the neighbor and then f go into the neighbor of L. Okay. In proof, so we have to do what? We have to, given epsilon greater than 0, we need to find the delta greater than 0. We need to find the delta, okay, such that this statement is true, such that if x go into the neighborhood of a from the right side, then f go into the epsilon neighborhood of L. Okay. When x go into the delta neighborhood of a on the right side, f go into the epsilon neighborhood of L. This is all we need to do. Okay. Find the delta. So let us going to practice in one question. Okay, in these questions, we still do two steps. Okay, the first step we're going to find the delta on a scrap paper, and the second step we're going to write down all the steps. So let me see. It's here, right? Okay, this is all we need to do. Given epsilon greater than 0, we need to find the delta, such that if x is going to the delta neighborhood of a on the right side, and then f going to the epsilon neighborhood of L, which means f arbitrarily close to L, if we take x sufficiently close to a on the right side. In these questions, so what is a? Let me write down. So a is 0, right? So a equals 0. All we need to do is find the delta. How? And by solving this inequality. Okay, solving this inequality, find what is the delta. So let me going to find what is f. F is square root of x. So all we need to do is to square root of x is f. L is 0, the limit, right? So minus 0. Okay, put the opposite value. We simplify a little. This equals square root of x. Okay, and then we need to less than epsilon. Okay, first we link delta first. Okay, x is less than delta, right? So square root of x is less than square root of delta. So that's good. And then all we need to do, if we set up, if I set up this equation, can you see? If I set up square root of delta equals epsilon, okay, we can solve delta, right? So we solve delta from here. We solve delta equals square both sides, we get epsilon square. This is the one we need. Why? Okay, if we pick this, you can imagine if we pick or we choose delta equals epsilon square, see, and the distance between the function and this going to what? So it's already less than epsilon, which means this is true, right? Good. So we find, let me write down the second step. All we need to do is write down now. Okay, so how to make? So the basic structure like this. All we need to make it clear is right. Given any epsilon greater than 0, we find the delta. We already find. So I say we choose delta equals. Let me go back. Delta equals epsilon square. Okay, square of epsilon. Epsilon square. You know this is the most important step. Good. After we find this, now we just make the statement true. What the statement? If x is going to the delta neighborhood of 0, and the function f going to the epsilon neighborhood of this 0, right? Okay, so let me write down if, and we say if x greater than 0, less than delta. Why? We don't have absolute value. Why? Because this is the right side. Okay, this means when x is going to the delta neighborhood of 0, x minus 0 on the right side, which means x from 0 to delta. And then what do we have? Okay, and then we look at the difference of the function and this 0, which means absolute value square root of minus 0. All I need to do is just copy what we wrote before. So simplify is this, and because x is less than delta, so square root of x is less than square root of delta. Because delta is epsilon square, so I plug in. So it's a square root of epsilon square, and then simplify. This is epsilon. So this is the statement. Okay, if x is going to the delta neighborhood of 0 on the right side, then the function of f going to the epsilon neighborhood of 0, which means epsilon delta definition, right? So we can make a conclusion. So by epsilon delta definition, okay, definition, we have the limit. We have the right-sided limit, right-handed limit, the function equals 0. That's the proof, right? See, all we need to do is find out what is the delta you need to choose. Okay, and from this statement we can see f is arbitrarily close to 0, right? Okay, so one more, which is for the left-handed limit. Can we see? You will see only a little bit of difference. Okay, what to do? We give epsilon delta definition, the precise definition for a left-handed. So the left-handed limit equals L. How do you say? F can, the intuitive is F can be taken arbitrarily close to L, can make F arbitrarily close to L by taking x sufficiently close to A from the left side or on the left side, right? So in the epsilon delta language, this is the language, how to say. And for every epsilon greater than 0, there exists delta equals greater than 0, such that x between this. This means which means x is close to a on the left side. See, x less than a, greater than a minus delta, which means x is in the delta neighborhood of a, but on the left side, right? Still, x is going to the delta neighborhood of a on the left side. And then we look at this statement, which means the difference of the function and L less than epsilon, which means f is close to L arbitrarily, okay? Or we say f is going to the epsilon neighborhood of L, okay? So very similar. Or the difference from the right-handed is here on the left side. On the left side, here is still epsilon neighborhood of L. So let's look at the graph. Okay, look at the graph. We can see what that these two neighborhood mean. And here is the graph. Okay, if the left-handed limit is L, which means what? F can arbitrarily close to L by taking x arbitrarily close to A on the left side. Which means if a given epsilon, f can be made into epsilon delta neighborhood of L, arbitrarily close. How? If x is going to the delta neighborhood of A on the left side. See, if x is going to here and y or fx is going to the neighborhood, the epsilon neighborhood of L, which means arbitrarily close, right? By taking x sufficient close to A on the left side. Okay, so how to prove? All we need to do is similar as before. Given epsilon greater than 0, we need to find a delta greater than 0 and make this statement true. If x go into the delta neighborhood of A on the left side, if, and then the value of the function go into the epsilon neighborhood of L, arbitrarily close, right? Okay, good. Let us go into practice this language, epsilon delta language, okay, on this left-handed limit. So all we need to do, keep in mind, is to find the delta. So we still do the same, okay. The first step, we find the delta on a scrap of paper. The second step, we copy everything here. Okay, so for these questions, can you see? All we need to do is do this, right? All we need to do is do this. By the definition, epsilon delta definition, okay, giving any epsilon greater than 0, no matter how small, find the delta such that if x is going to the delta neighborhood of A on the left side, this is on the left side, right? Okay, the left side, and then f going to the epsilon neighborhood of L, okay, arbitrarily close by taking x sufficient close to A. For these questions, what do we need to do? What is A? A is 4. Let me put here. A is 4. Okay, and of course f is there, L is 2, right? All we need to do is find the L, find the delta. How? Always the same. This is inequality. Resolve the inequality. Do this. Resolve this inequality, find the delta, so that this is true. Okay, so we are going to do what is f? We were going to explore this x inequality. Fx is square root of 2. Okay, so I was going to do square root of x minus L is 2 minus 2 absolute value. Okay, less than epsilon. From this inequality, we need to find the delta. Where is delta? Always keep in mind that delta is the distance between x and the number A, right? X minus 4 is linked to delta. So we need to find x minus 4. Where go to x minus 4? Rationalize, okay, rationalize. Can we see? Rationalize, we can get this. So this is a square root of x minus 2. Let me do this. Put square root of x plus 2. Rationalize, right? This is conjugate. And plus 2. Okay. You know, this is a rationalize. Okay, after rationalize, now can we see what do we get? The upper here. And this is the difference of square. This square is x minus 2 square is 4. So what do we get? We get x minus 4. Can you see? This is what we need, right? Over denominator is still there. I put x squared x plus 2. Probably someone say, how do you resolve this less than epsilon? We know. Okay, so can you see this? I separate this. Okay, separate into 2. The first is 1 over square root of x plus 2 times the absolute x minus 4. Okay, this looks better. Okay, how to do? And this is less than epsilon. Okay, we can control two parts, each part. The first part, the second part. Okay, the first part, we look at the first part. Okay, because x is close to 4. Imagine if x is close to 4, definitely we can control this part. How? And easy to say. And I say because x is close to 4, I will take x greater than the number x greater than 1, the easiest number. When x is greater than 1, so this should be less than 1 over 1 plus 2, which is 1 out of 3, 1/3. Okay, how to make this first? Wait a little. So let me go to see. Okay, so we have a two part. We can control each part. I will going to control the first part. I say because x is greater than 1, so this part is less than this, less than 1/3. Of course, how to make this? This is delta 1. Okay, so this time we have delta 1 equals 3. What does this mean? Means this. So let me write down. Okay, so here is 4. If delta 1 equals 3, the neighborhood of 3 of the 3 neighborhood of 4, which means this is 1. Can you see this? And this delta 1 equals 3. That means all the x will go into here. This is what? The left side, right? What do we see? We can get x is greater than 1. If we pick delta 1 equals 3, and all the x will go into here, which means all the x greater than 1. All the x greater than 1, so this part will less than 1/3, as we just did. Okay, did the first. Now we look at the second. The second is easy. X minus 4, so we can say it's delta 2. If we make a delta 2, okay, so here is like a I directly say less than delta 2. Why? Okay, that's all we need to find the delta, right? So we find the delta 2. So delta 2 is what? I can make a delta 2 is this is 1/3. The first part 1/3. The second part I pick 3 times epsilon. Okay, and how? We just say delta 2. We find that delta 2 is this, and then the second part is less than 3 times epsilon. So we have the first control, the second control, and when, okay, the first happen, the second happen at the same time, you know, less than delta 1, less than delta 2. So we have to make this. We have to pick. Okay, delta is the minimum of delta 1 and delta 2. Okay, can you see this? Okay, so this is the peak. If we pick this, now we have this inequality is true. This inequality also true, which means what? Okay, see. And now this is less than 1/3 is the first part. The second is less than 3 epsilon. And then do calculation, we get epsilon. That's all we need, right? This is less than 1/3. This is less than 3 times epsilon, so it's epsilon. Okay. The first true, the second true, because what? Because we pick delta is the minimum. Okay, and if we have this, see, and is this true? Yes. If we choose delta is the minimum, and then we say the difference between the function and the 2 is less than epsilon. Okay, good. So we already found the delta. Keep in mind, we're going to write down everything. So this is all we need. Write down everything to here. Can you see? Okay, so now what do we find? Okay, so how to write down the same structure? Okay, so given any epsilon and we choose delta and then make the statement true. Okay, so is given any epsilon greater than 0. We just already choose. We find that delta equals how many? Do you remember the minimum of let me see, delta 1. What is delta 1? Delta 1 is 3, so the minimum of 3. Okay, and the delta 2 is 3 times sigma. Okay, so I put it here. So the first is 3, the second is 3 times epsilon. So good, so this is the most important, so we'll copy here. And then what do we have? I can write down the statement. We say the statement true. What is the statement? When x is going to the delta neighborhood of 4 on the left side, and the f going to the epsilon neighborhood of 2. Okay, so which means this. If, okay, can we see? And if 4 minus delta less than x less than 4, what does this mean? Means x is going to the delta neighborhood of 4 on the left side, then the value of the functions going to the epsilon neighborhood of 2. Okay, so we're going to write, which means x square root of x minus 2 do absolute value. And I copy what we did. Okay, rationalize, right? So we rationalize first. Is square root of x minus 2. So I have to times square root of x plus 2 times square root of x plus 2. Okay, and then the absolute value. You know this we call the rationalization. And after this is the difference of the difference of square, and then we do simplify. See, the top is x minus 4. The bottom is still copy. Okay, and then we make it into two parts. The first part is 1 over square root of x plus 2 times the second part is x minus 4. Okay, as we did, because it's in the 3 neighborhood we wrote before, right? So the first part is less than 1/3. Okay, and the second part is less than what? The second part is less than 3 times epsilon. Okay, is less than 3 times epsilon. I directly put is I put 1 more. Okay, so times delta. Okay, this is less than delta, right? So this is x minus 4. The distance is less than delta is from there. And then upper log, delta should be less than or equal to 3 times epsilon. So this is 1/3 times 3 epsilon equals epsilon. Okay, it's good. So you finally find it. If x is going to the delta neighborhood of 4 on the left side, the value of the function goes to the epsilon neighborhood of 2. That's the epsilon delta language, right? Good. So we make a conclusion by epsilon delta definition, and we have the left-handed limit. When x approaches 4 from the left side, square root of x equals 2. Okay, that's the proof. That's all. Thank you.